Hello, I'm Drew Barbier, Vice President of Product at MIPS. I'm excited to be your host for our new podcast series, Data Movement and Processor Architectures. In this podcast series, we'll dive into ways to achieve more efficient data movement and provide insights on current and future processor architectures. If you're a systems designer or an architect looking for ways to gain more compute efficiency, this podcast is for you. So in today's episode, we're going to talk about accelerating automotive compute, specifically in software-defined vehicles, autonomous driving, ADAS, as well as AI, because AI is a hot topic today. My first guest is Vasanth Waran, who leads the MIPS automotive business. Vasant has 22 years of experience in the semiconductor industry and spent a majority of his career at Intel and Qualcomm in roles for design, product development, applications and marketing, as well as product management. Vasant was instrumental in building the automotive business at Qualcomm, and in his last role before MIPS, he was to reestablish Renesas as a key supplier of automotive solutions in the ADAS and IVI space. Vasant, welcome.
Glad to be here with you.
So I have a couple questions for you. First one's going to be easy, okay? So can you give the audience a background on what ADAS is, and then tell us some of the key advancements that you've seen recently, and what do you think about the future of ADAS? Yeah. You know, it's a conversation we were having recently, right? Just last week.
Yeah, it's an interesting time when it comes to self-driving cars or ADAS, right? So ADAS is, if I were to explain it to a 5-year-old,
I'm 5.
Yes.
I had a 5-year-old, yeah.
Sure. So the layperson, I would say ADAS is it's a fancy term for self-driving cars, or at least assisted driving, or steps going towards fully autonomous cars, right? And it's been quite a journey in the last 10 years. I think maybe in 2012, 2013 is when people started talking about it, and we were supposed to have self-driving cars already, right? If you think about CES and a few of the shows in 2019, everybody was talking about, we're going to have self-driving cars. And there used to be arguments over beer about are you even allowed to drive, or is it all going to be self-driving cars? I think in the last 2 or 3 years, it's sort of, the rhetoric sort of was pulled back a little bit. Part of it because I think the technology wasn't there. And now finally, I think we're starting to see more towards, I'm not going to say fully self-driving cars, but we're pretty close to getting to almost autonomous cars, right? Okay. Interesting times, the technology is there, the software is there. I think, especially here in the Bay Area, you can see Waymo or any of the other robo-taxis driving around. So I think we're getting closer to it than we were maybe about 2 or 3 years ago.
Okay. And so if you were to describe the future of ADAS, it's all about this autonomous driving.
Correct. I think we'll have steps before it becomes fully autonomous. And I always associate driving with freedom, right? And everybody, I think when we're teenagers, want to get away from the house and get into a car. So I think those people would still want to drive. So 10 years from now, you would have the choice of the car being fully autonomous, in my opinion, or you would have the option of driving it when you choose to, right? I think it's just when you're in a daily commute, you want to have something that's assisting you in getting you to a destination. I think we'll be there in the next 3 or 4 years.
Yeah. So I'm with you. So I grew up in the country, and so we couldn't go anywhere without driving.
Yeah.
Now I live in Austin, Texas, in the city, and when you take those late flights in and you get to the airport at 1 a.m. in the morning, I think having my car drive me home is something I definitely want.
Exactly. I think everybody wants to drive on the weekends and not during the week.
There you go. There you go. I like it.
Yeah.
All right. So with that, do you want to tell the audience a little bit about the P8700?
Yeah. P8700 is, we're releasing P8700 to our broader audience at MIPS. MIPS has always been about moving data. So we're in the center of this revolution in moving from bytes to gigabytes to terabytes in the car. We've done that successfully in the other compute spaces, whether it's consumer, embedded, or the data center market. Now we're adding automotive to that. We've been an automotive supplier for many years. I think P8700 is going to be, it's our first RISC-V ISA instruction set architecture compatible release from MIPS. But it's going to build on top of about 15 years of legacy that we've had in being the dominant choice in autonomous driving solutions in the market today. If you see an autonomous or a self-assisted or a driving-assisted car in the roads today, it probably is running on MIPS. It's the older MIPS products, but 8700 is now the next step. It's taking it a step forward in terms of making autonomous driving a much more affordable and scalable.
Yeah, very cool. Yeah, we're very excited about getting our first RISC-V compliant product out there with the P8700. You were talking about data movement. You want to spend a little bit more time on why that's important in the automotive space?
Absolutely. I think anybody who's seen a self-driving car or an autonomous car, you'd see it has a lot of cameras, it has a lot of sensors coming in, and there's a lot of real-time processing, right? You got to take the data from the cameras, you got to fuse it together. A lot of times you have to stitch the images. If you want to get more technical, it gets written in memory, you pull it back, you process it. And AI, machine learning is the rage right now. So all these autonomous cars will have some sort of AI processing in there, right? So you're taking the sensor data, you're sending it into the AI processing engine, then it comes out of that. And whether it's the human or the car, it needs to make a decision on, okay, I got to change the lane, I got to keep some distance between me and the car in front or whatever, right? Quite a bit of data movement, right? So from the camera into the processing element, back into some other decision-making authority, and then onto a screen.
Yeah.
And all this needs to happen in a very, very short amount of time. And if you're driving, you talk to the German automakers, they're like, oh, you're on the Autobahn driving at 200 kilometers an hour.
You drive at 200 kilometers.
Me, I'm slow.
I always drive for a second.
I've had quite a few tickets in my life, so I always drive at the speed limit.
Okay.
But you have to process this at a very, very fast pace, and that requires efficiency, right? So you can't, it's not...
Hold on. So you drive slow because you can't process it fast enough?
No, I'm just a careful driver.
Okay,
right?
Okay.
But the data in the car needs to be processed and displayed or decision actuated in a very short amount of time.
Right.
That requires processing of whether it's a small amount of data, what we call as bytes, to terabytes, right? Machine learning typically has a lot of input sensors coming in, weights, if you will. And that's a lot of data. So to do that, you need a very effective, efficient data processing engine. And that's why our tagline is moving bytes to terabytes, right? Whether it's a small amount of data, but you have to make a quick decision, or you got to process a lot of data, whether it's terabytes. That's where P8700 excels.
Very cool. You touched on AI in the car. AI is the buzzword right now, right? So where do you see AI driving automotive technology in the future? We talked about autonomous driving, but what does that really mean inside the vehicle and the electronics in the vehicle?
Okay, AI is here to stay. It's going to be one of the big factors in terms of this journey when we talked about where do we see cars in 5 years from now, right? AI is going to be the one that drives us along that path. But one of the challenges that I see in the market when we talk to our customers, the pain points that we see is there seems to be this arms race towards creating more and more AI in the car, right? Sure, everybody loves to have more compute, more capability, but a car is a really tough design environment. I've done, as you talked about my history in the past, right? I've done desktop chips, server chips, phone chips, right? But nothing is as challenging as a car because you're in an environment which doesn't allow for a lot of cooling. Your temperature tends to go up, and with that, there are a lot of issues in silicon manufacturing and reliability. So you cannot keep pumping the performance up without hitting some sort of thermal limit or physics limit, right? And that's why I think it's all about efficiency. And again, this is where we're really good at providing an efficient coprocessor. A lot of times when the AI engine is doing some processing, we can offload some of the pre-processing or the post-processing, or making sure that the data formats that the AI engine uses is available in the right time and in the right format. It's also about making sure that all the resources in the system are utilized completely. So today, if you look at some of the other solutions in the market, they're not as efficient as what we bring. So when we talk about AI, it's not only about machine learning or neural network processing capability, but it's about making sure that you have the right amount of performance and utilization is at the maximum. And that's where MIPS provides a difference compared to some of our competitors.
Okay. All right. So what role do you see sensor fusion in this whole AI, ADAS, autonomous space? And what are the requirements that it sort of drives?
Yeah, it's hard to sort of put it in one sentence, right? So let me give you an example, right? As you... the Society of Automotive Engineers, SAE, they have different levels of autonomous driving. So today we're probably about an L2, L2 plus, level 2, level 2 plus, which is typically 5 cameras, maybe 6, 7 cameras, 4 radars. But then as you move along, it gets to about 12, 13 cameras, and then 7 radars, and then LiDAR, if it It's going to be political debate here, but if LiDAR ever gets cheap, then you would integrate that in a car as well, right? So now you have all those sensors, so the data rates can go really high. So you're talking about 100 gigabits per second to 200 gigabits per second. That's a lot of data to be processed at any time concurrently, right? So that's the challenge that you have. And you have to take output to one stage, process it, and then send it out to the actuators as we talked about.
So we're getting back into the data movement again.
Right. It's all about data movement. You want to take a chunk of data from one place, move it to another place where it's processed, and then utilize completely, right?
Right.
You don't want to have any choke points.
Yeah.
Yeah.
Okay. So switching gears just a little bit. So I've been in the RISC-V space for quite some time. I've always been on the IP provider side. Right. You have a little bit different perspective because you come from more the silicon side. So I'm curious what your take is with that experience on the whole RISC-V versus ARM or legacy architectures and how that might have changed over the past couple of years.
Every region is now getting deglobalized, if that's even a word, right? They want to have supply and independence. They want China, India, US, all of us want to sort of control our own future in terms of investments in AI. And automotive is at the center of it because autonomous cars is a big area where AI gets deployed. And I think one of the benefits of RISC-V is it gives you an independence from one supplier, one region, right? So OEMs or customers can go off and given that it's an open standard, as long as everybody is, their suppliers or their IP vendor is RISC-V compliant, they have the option of moving things around, right? Now, as an IP vendor, I wouldn't want to do that, right? I want to be as sticky as possible, but I also understand the need for some standards where we're all developing to it, so you can build a broader ecosystem as well.
Yeah, ecosystem, right? It's about software, right? And giving the OEM some of that flexibility back to kind of control their own destiny.
Absolutely. And you talk about software. I think the other buzzword that you always hear is software-defined vehicles.
Yeah, that was my next question.
I can read the future.
Yeah.
And it's all about, I think automakers one of the challenges that they have is the traditional automakers, the ones that have had gas or ICE cars in the past, or right now as well. They take a long time before it hits the market. So the development cycle is about 5 years. Now, the beauty of new EV vendors such as like Tesla or some of the Chinese vendors is that they can move much faster, right? And that's primarily because they don't have the number of car lines that the older OEMs have. But it's also because they're innovating very fast using new technology like RISC-V, MIPS IP, and so on, right? And that's the benefit of going to something like RISC-V, especially with MIPS, because you get the best performance. It adheres to a standard, and you can move back and forth between different suppliers as we talked about. And the other big thing that's happened, and I was on the other side, right? Just a few years ago when I was at Qualcomm and Intel, the question I would ask someone like you is, where's the ecosystem? Can I run a certain OS or not? And as every day goes on, I think that bar is getting, all the walls being scaled much easier, right? I think there's a very broad ecosystem support. So this argument is now, if not moot, I think it's getting weakened as every day passes.
Right. And on software-defined vehicle, my understanding is it's really more about the vehicle architecture and how you sort of defining new platforms, right, and that's driving some of these changes. Can you maybe just help articulate a little bit what's different in a software-defined vehicle architecture versus a traditional one? Yeah,
sure. The software-defined vehicle is, it's exactly as it sounds, right? It's a vehicle that is defined by its software adds the definition for the features you get. A good example is you could buy a car today. It would have the capability to have new features added on 3-4 years down the line. You don't have that option today unless you take your car to a dealer.
I guess what I'm trying to drive home for the audience is why don't they have that option for the older generations of design?
It's because I think it's a design philosophy. It's a design methodology, right? I think it's software first is what a software-defined vehicle is, right? You come in with the software architecture and then you define the architecture of the hardware around the cars around it.
Right.
Whereas in the past, it's always been like, oh, I'm going to use a chip from TI, NXP, what have you. And then you define the software around it. And what happens is, for the lack of a better word, the software experience is much more clunkier, right? Because as we all know, we wake up and sleep with our phones. the phone OS changes almost every 3 or 4 months, right? And the same thing is happening in the auto space as well. You have to keep up with the latest OSs. You have to keep up with the latest safety standards. And that's where being software defined first helps, because you can build the architecture around new experiences that you're going to get down in the future, and then design the hardware to meet those requirements, right? Not the other way around.
Right. Traditional designs, they design it for a block or a component, but in the software-defined vehicle, the whole architecture is sort of defined as a whole to give you this experience that you're talking
about. Exactly.
Okay.
Yep.
I finally understand it. Okay, let's get people excited about the future. How do you see the automotive market changing in the next 5 years?
I think it's a challenging time. One of the things that has happened in the last 2 years is, as people know, right maybe in the middle of COVID, I think electric cars were starting to be the rage, and then I think the supply chain dependence and all that, the cost became prohibitive. So we're coming out of that. As I mentioned, I think compute is getting to a point where I'm going to say there's line of sight to L3 and maybe even L4 cars in the next couple of years. So it's exciting on both fronts. I would say the burden is on us to ensure that we're able to provide compute in an efficient and a scalable and an affordable manner, right? I will never believe in just throwing more compute resources just because you can. You always need to be cognizant of the challenges that our customers face. And that's where I think I'm really excited about P8700. It's going to be the first step that we take. We've got more products coming in the pipeline. I think it's going to enable a lot of stuff in the SDV world and the ADAS world as well.
Very cool. Well, I'm super excited. So I'm going to wrap this up with Taylor Swift.
Okay. Oh, boy. All right.
So my daughter is 8 years old.
All right.
So she claims she's not a Taylor Swift fan, but she knows all kinds of Taylor Swift fans. Taylor Swift is doing her tour, and she's in cities for 3 nights in a row because it takes that long to have all her fans come and see your shows. So given that, do you think the Kansas City Chiefs are going to three-peat in the Super Bowl?
My daughter's a Swiftie.
Yes,
and I loved it because for the first time she would sit and watch a game with me.
Yeah?
And so I'm looking forward to this Chiefs, at least making a long run of the playoffs so I can enjoy January and February with her. And the other thing is I want to see a team win 3 in a row in my lifetime.
Yeah.
So this is probably the closest it's going to get, at least for the next few years. So yeah, I do hope they get it.
Taylor Swift is bringing the football fans home.
Absolutely, yeah. Dads and daughters, right?
That's right. All right, well, thank you, Vasant.
Thank you, Drew. Thank you.
That's all for our podcast today, a podcast of data movement and processor architectures. You can automatically download the next episode as soon as it's available. Just follow the show on Apple Podcasts, Spotify, YouTube, or your favorite podcast app. And for more insights, follow MIPS on LinkedIn. That's MIPS. You can also follow us on Twitter at MIPS_RISCV. MIPS_RISC-V. Today's episode was produced and edited by Cody Goff. Thanks again, Vasant, for joining me.
Thank you.
And have a great week.